Now let's go a step further by calculating where the resultant force acts. And specifically for this example, I'll be trying to figure out the y location where it acts. There will be a separate one to figure out the x location where the resultant force acts. But for this video, I'm just going to calculate the y location. Recall, just via looking at the picture to the left here, that the y center of pressure, I'm going to define that relative to the location of the centroid. So by definition, the center of pressure is located at the place where the moment is due to the resultant force would be equal to what you would get by actually directly doing the integration. So y sub Cp, so the location of the center of pressure times the resultant force, should be equal to y times the pressure integrated over the area. So what's left to do is then just replace the pressure with rho gh, right? So that's rho times g times, so h is equal to xi times sine theta, so I'll just do that replacement directly. A few things out of that integral, so like the rho, the g, the sine theta, none of that stuff depends on the element of area. And then xi itself can be defined using both the location of the center of gravity and the local y coordinate that's measured relative to the centroid. In that case, you get rho times g times sine theta, and then you can break the two terms in the integral apart. The first one involves the center of gravity and another term that involves y, but integrating y over area, so we've already seen that before, since y is defined relative to the centroid, that integral is by definition 0. The other term that's left over involves a y squared dA, and that term is not 0, but again, since y is defined relative to the centroid, that actually is the definition of the moment of inertia of an object with respect to the centroid. So in the end, you can, calculate, so we'll divide by the resultant force. So you can calculate that the center of pressure is located at minus rho g sine theta times the moment of inertia with respect to the x axis divided by the resultant force. And just as a reminder, that resultant force was equal to rho g h measured at the centroid of the object times the total area of the object. And so that gives you a formula to calculate the location where the center of pressure acts.